Alright guys, welcome to Unit 4 Quiz 1 Study Guide Help video. I'm going to be going through the even problems. The odd problems are there as extra practice if you're interested, and the answers are provided to the odd problems at the end of the document. So let's go ahead and begin here with number 2. Just a couple of vocabulary checks to begin with here. So what's a binomial? A binomial is the sum or difference of two monomials. So from number 1 you saw that a monomial is a number and a variable or a variable being put together. Well, if you just have two of those things then being added or subtracted, then you've got a binomial. So this is an example of a binomial. You don't have to give an example, but I'm just providing one to bring the definition to life. But this is the answer. It's the sum or difference of two monomials. All right, let's go ahead and take a look at number 4. What is a quadratic polynomial? So quadratic means that we have a polynomial where the highest power is 2. So for instance, this would be a quadratic polynomial because the highest power is 2. Now this one's asking us to give an example, not define, but give an example of a quadratic monomial. So a monomial is when you have a number and possibly a variable. And in this case we have to have a variable because it needs to be quadratic, and quadratics have powers of 2. So this is an example of a quadratic monomial. It's only one term. Now we want to give an example of a quadratic trinomial. So we could just take the answer from the last one I did, from number 6, write that, and just add a couple other terms on there and we'll be in business. So that's an example of a quadratic trinomial. A trinomial is a polynomial that has 3 terms that are being added or subtracted together. And it's quadratic because my highest power is a 2. So it's a trinomial because there's 3 terms, and it's quadratic because the highest power is 2. Give an example of a linear monomial. All right, so a linear polynomial is one where the highest power is a 1. So here's a monomial, and if I just let the power be a 1, then that would be a linear monomial. Now you don't have to write the 1 if your power is ever a 1, just so you know. So this would be a good example for number 10. All right, now we're going to get into the calculation kind of stuff. So number 12, we're going to be adding two polynomials. We have an addition symbol here, and then we have the two polynomials that are being added. And basically, when it comes to addition, all you need to do is combine your like terms. Like terms are two monomials that have the same variable and power. So for instance, this one has an n to the 3rd power, and so does this one. So I could put those together. Now the way that you add like terms is simply by adding the coefficients, or in other words, the numbers in front. So if I add 2 and 3, I get 5, but the variable and the power will stay the same. So that's how you combine like terms. All right? Next, we have an 8n squared, and we also have a 5n squared. So those are like terms. I can combine those also by adding the 8 and the 5, and I get 13n squared. And then finally, we have this 7n and a negative 7n. Now, 7 minus 7 is 0. But when you have 0 as a coefficient, we really just don't write it. And so basically, these just cancel each other out. And so my final answer is 5n to the 3rd power plus 13n squared. And that's the final one. Now on number 14, we're subtracting two polynomials. Here's my subtraction, and here's my two polynomials. Now when you're subtracting, This negative, you're going to think of that as a negative 1 that you're going to distribute into this whole thing because you're subtracting that whole second polynomial over there. So the first one's going to stay exactly the same because we're not doing anything to that one, the first polynomial. But this second one, all the signs are going to change because we distributed a negative 1. So the 5 becomes minus 5x squared. The positive 7 becomes a negative 7x cubed. And then the negative 4 becomes a positive 4x to the fourth. So after you distribute, you go ahead and combine all your like terms. Now, this one doesn't have any variables, and there's no other terms up here that have no variable. So that one's going to stay just the way it is. Next, we have a negative 7x cubed, and I have another x cubed over here. So we can combine those. Negative 7 and negative 7 makes negative 14x cubed. Next, we have an x squared term here, 8x squared, and here's another one, 5x squared. So we have a positive 8, take away 5 will be 3x squared. And then finally on the very end there we have a lonely one with nothing to combine with. It's the 4x to the fourth. So that just comes down because there's nothing it combines with. And just so you guys know, a lot of times they're going to put these things in order from the highest power to the lowest power. So the highest power is 4, so that means that whole term is going to come to the front. The next power that's biggest would be the 3, so we'll put the negative 14x to the third next. The next biggest power is 2. So we'll put that 3x squared next, followed by the 1 here that doesn't even have an x on it. We'll just put that at the end. Usually the constants just go at the end there. And that would be our final answer there. All right, so number 16 is just a bigger version of what we did. We just have 3 polynomials now that are being subtracted. So now for each one of these subtractions, we're going to distribute. So I'm going to distribute a negative 1 here, and I'm going to distribute a negative 1 here as well. So all 6 of these terms are going to change their signs. The first one will not change its signs because we're not distributing. There's no negative in front of this first polynomial, so all these 3 stay the same. But the rest are going to change their signs. So we have negative 5a cubed minus 3a plus 8a to the fourth minus 7a plus 5 and minus 8a cubed. And now we just get to find all of our like terms. So let's start on the right here. I've got an a cubed. Are there any other a to the third powers, also known as cubes? There's one, and there's one. There's 3 of them. So I need to combine 6 minus 5 minus 8. So what is 6 take away 5 and take away 8? Well, 6 minus 5 is 1, and if you take 8 away from that, you get negative 7. So negative 7a cubed. Next, we'll do the squares. So let's find all of our squares. There's an a squared. I don't see any other squares up here. So since there's nothing for that to combine with, I'm just going to bring it down just the way it is, and we'll move on to the next one. Here is a 4th power, a to the 4th. I see one of those here. So negative 6 combined with a positive 8 is a positive 2, a to the 4th. We have a negative 3a and a negative 7a. Those are like terms. They both have an a to the first power. So negative 3 take away 7 is negative 10a. And then finally we have this 5, which is just a constant all by itself there. We want to put this in descending order, though, from the highest power to the lowest. So this guy should be in the front. But the rest of them are already in order. The third power, followed by the second power, followed by the first power, followed by the constant. And there you go. So that's combining polynomials with addition and subtraction, and now we move into multiplication. So in this case we have a number on the outside, and we're going to distribute it into the inside just by multiplication. So 7 times 6 is 42. 7 times 8 is negative 56 in that case because it is a negative 8. And 7 times 5 is negative 35. And we're all done. So notice all I did was I multiplied the 7 by each of these coefficients. I think I'm going to back up though, and I'm going to do number 17 as well just to make a point. Well, not 17. Let's look at 19. I'll do number 19 also. In this case, we're still going to multiply the 7 times the 7 times the negative 8, and the 7 times the negative 1. But this m is also getting multiplied. So how does that work? Well, when you multiply monomials together, let's say I want to multiply those two together. We do the 7 times the 7, which is 49. And when you do m times m squared, you add their exponents. So the exponent of this m is a 1, and the exponent of the other one is 2. So 1 plus 2 is 3. Let's do the 8 now. I want to multiply 7m times 8m. Well, 7 times 8, negative 8, is negative 56, and m to the first times m to the first would be m to the second because you add the exponents. And then finally we have negative 7 times negative 1 is negative 7, and the m is going to stay the same because this one doesn't have any m's to multiply with it. And there we have it. All right, let's go ahead and jump up to number 22. Is that what I wanted to do? Let's do number 20. All right, number 20. So now, when you want to multiply two binomials, the strategy that we learned in class was something known as the box method. So we're going to draw a box. You're going to put one of your binomials along the top, the 2b and the negative 8, and your other binomial down the side, 8b plus 7. And what we do is we just multiply to fill in the box. So to find this space, I'm going to multiply these two together, the one above it and the one to the left of it. So 8 times 2 is 16, and b times b is b squared. To get this box, I multiply this number to the left and this number above it. So 8 times negative 8 is negative 64, and the b just stays there because there's nothing for it to combine with. To get this one, we multiply the 7 and the 2b. 7 times 2 is 14, and once again, there's just going to be one b there. And our last box is filled in by multiplying these two numbers, and that is simply negative 56. So these four things are the result of the multiplication. So I'm going to take them out right now and write them in order from highest power to lowest power. But a lot of times when you have these boxes, you're going to have some like terms. So these are like terms here. The negative 64 and the positive 14 can be combined. And if we put those together, we're going to get negative 50b. And that's our final answer there. Now, to save yourself some work, if you can do some mental math, instead of writing the step there that I just erased, you could just write the first answer here, the last answer here, and you can get this answer simply by combining these middles together, those diagonal numbers, if they're the same term, and usually they'll be like terms. Not always, but usually. All right, let's go ahead and take a look at number 22. Now notice this one is a binomial and a trinomial, and because of that we need a bigger box. We need a 3 by 2 box. I need it to be 3 spaces long for the trinomial and 2 spaces high for the binomial. So I'm going to put the binomial here down the side and the trinomial here up along the top. And we fill in the box the same way that we did before by multiplication. So this would be 64 m to the third, negative 32 m squared, negative 64 m, followed by negative 64 m squared, 32 m, and positive 64. So I have a 64 m to the third power Notice that on this diagonal I've got like terms, so I can combine those. They're both an m squared. So negative 64 and negative 32 would be negative 96 m squared. Next we have these two. Those are both like terms. They're both m to the first power. So 32 take away 64 is negative 32m. And then finally we have a 64. Now these numbers are really big and unpleasant. I don't mind if you guys use a calculator to do your addition and subtraction. That would be completely fine with me. But this is our final answer. All right, now we could do the box method on this and it will work. But the reason I've included this is because this is one of our shortcuts. This shortcut is the one that looks like this. A plus b times a minus b. So when you have two binomials that are exactly the same, it's just that one's a plus and one's a minus, all you have to do is multiply the first ones together and multiply the last ones together, and you're done. You don't have to do a box method on this one. So the reason for that is because the middle term cancels out. But let's go to the shortcut here. So 6p times 6p is 36p squared, and negative 4 times positive 4 is negative 16, and we're done. But remember, that shortcut only works if they're exactly the same, just one's a plus and one's a minus. Okay? So that's a shortcut that we learned. Let's take a look at another shortcut. This one here. All right, now when you have a binomial being squared, that really means that you're multiplying that binomial by itself. And so once again, you could just do the box method and it will work. But I've shared a strategy with you guys, another shortcut. How this shortcut works is that when you have a binomial being multiplied by itself, you multiply the first numbers together, you multiply the last numbers together, then you multiply these two inside numbers together, and you put a 2 in the front. And then you're all done. Once again, the box method works, but shortcuts are nice. So let's use our shortcut here. I'm going to multiply the first numbers together. I'm going to multiply the last numbers together. Finally, I'm going to multiply these two here together. 6a times 5 is 30a. But if I multiply that times 2, I get 60a. And then you just put a plus in there. Now it's possible that the answer will be written in descending order, so they might put the 36a squared first, followed by the 60a, followed by the 25. But either way, that looks like a good answer to me. And that'll do it for today. So hopefully that was helpful. If you guys want any extra practices, just do the odd ones that are with them. And those answers are provided on the back sheet for you to check yourself. All right, so we'll see you guys in class. Have a good day.